Muy buenas tardes. ¿Se oye, no? Perfecto. Bueno, vamos a dar comienzo a este evento, un poquito tarde. Lo sentimos, hemos estado aquí haciendo un poco de ajustes y demás. Nuestra compañera Inma, que ha estado también organizando todo esto, ha tenido un problemilla en casa, ya está de camino, así que bueno, ya hemos superado las tragedias y demás, así que vamos de lleno a meternos con esto. Bienvenidos, muchas gracias, como digo, a este evento de comunidad. Llevamos ya prácticamente un año organizando estos eventos cada trimestre. Cada vez pues, vemos mucha más asistencia y mucho más interés. Y cada vez las charlas pues, tienen mucho más nivel, con lo cual pues, creo que vamos en la buena dirección. Mi nombre es Raúl Marín, soy parte del equipo de Grafana Labs, que junto con Gonzalo Pina, también compañero de Grafana Labs, somos del equipo de comercial. Iniciamos esta comunidad y bueno, pues agradecemos que estés por aquí, agradecemos también al equipo de Globo que nos ha cedido las instalaciones y bueno, la verdad es que son impresionantes. Yo creo que cada vez nos superamos más, ¿no? en las instalaciones, los dispositivos que tenemos para hacer las grabaciones. Comentábamos antes también de manera jocosa que los primeros vídeos los hacíamos con mi portátil, se veía ahí el careto del personal en la cámara web y luego un micrófono de estos ni siquiera inalámbrico, que nos íbamos tropezando y demás, pero bueno, al final lo importante es echar este ratillo de aquí, compartir conocimiento, que lo hagamos un poquito de networking al final para que podáis contar vuestra experiencia y quién sabe, a lo mejor en el próximo evento podéis contar vosotros vuestra experiencia. Hoy tenemos también dos charlas, yo creo que muy top. Tenemos a Víctor, que va a abrir ahora el turno de charlas. Y luego tenemos un compañero de Grafana, Pablo Chacín, que va a hablar de K6 también. Ahora os introducéis vosotros, mucho mejor que nosotros. Y con eso, pues, damos el pistoletazo de salida. Roldán, ¿quieres unas palabritas?
Nada, estaremos por aquí después al final. Preguntarnos lo que queráis. Tenemos pizzas y cerveza por ahí también. O sea que invitado. Y nada, muchas gracias a vosotros.
¿Hola? Sí, ya está.
Okay.
Okay, so welcome everyone here. I'm working in Globo. My name is Rodan. We are letting the facilities here for the Grafana people. Usually in Globo, we do meetups the last Thursday of every month. We have Globo speakers. This time, but we also are letting the space for any other group of meetups in the city, like in this time Grafana. You are very welcome here. So to take the opportunity to tell you about Globo, sorry, it's just 5 minutes. I hope not boring you. The meetup that I was mentioning, I don't know if you use Globo, but is any user from Globo here? Mission is to give everyone easy access to anything in the city. So it's not just food. We are also selling any other thing. We're delivering you any other things. You can buy things from FENAC or for any other place. Remember, it's not just food. You can have even your groceries in like 5 minutes or 10. We're in 25 countries. Maybe you were not aware. We are not only in Spain. We are in many places in Europe, in Africa, and even in Middle East. We're in more than 1,500 cities, and we have more than 1,300 multi-active partners, different places where you can buy your food or your different stuff. But stop talking about general stuff. Let's talk about engineering. We do what you want. I joined like 5 years ago. We were like 30 engineers. Now we are over 600, split in more than 100 teams and 13 different clusters. For me, it was a big change. But we need to support operation for different things everywhere. Well, some of our challenges these days are we are trying to move away from our monolithic apps, not only in the backend, also in the mobile apps. Everywhere, I think this is a problem everyone has been facing. You start small, putting everything together, and we try to imitate the big ones going to services. We are also moving into better reliability. Actually, we have Gaston today that is going to do a talk next month about high availability systems. welcome to come next month to this one. And of course, we really care about the developer experience, and of course, observability is one of these things. Since the event from Grafana is about observability, especially in Kubernetes, I was picking just some numbers because we are also moving into a Kubernetes architecture in Glovo. Currently, we have 42 services, which is about 50% of the services that we have. We started this like around 6 months ago, and this is how we are progressing. This is some of the benefits that we are seeing with Kubernetes. We have really more faster deployments, for faster rollback, and we will everything faster. Regarding observability, which is mostly the talk today, I'm sorry to disappoint you, but we are not using Grafana here. But we are mostly into Datadog. Oh, actually, the log of Datadog is conveniently hidden there. It's in the top, but fine. I was picking some data just some minutes before this meetup. We have 12,000 different metrics, 20,000 different monitors that to have alerts on anything about these metrics, 4,000 different dashboards. 3,000 of them were updated during the last year, so I hope they are not legacy. But 1,000 look like they're legacy. And we are quite happy with the way to observe in Datadog, but this is what feels when you use Datadog. It's like not a lot of money. So my last 6 months has been trying to cut costs in Datadog in the parts about mobile, which is what I'm focused. And I mean, I didn't want to lose more time for you on this. This was all that I wanted to share. So welcome to the Grafana speakers. Is you.
Okay. There we go. Okay. So, this is going to be a bit complicated because I did not really prepare. I had like 1 hour to prepare a talk. I didn't want to talk about the things I already talked in the past and things like that. I do that a lot. So bear with me. It's going to be very rudimentary what I could do within an hour, right? And what I tried to accomplish in that hour was to figure out how I can observe everything happening anywhere, right? Doesn't matter whether we're talking about Kubernetes cluster or we're talking about AWS or Azure or anything, doesn't really matter. But observe what's going on from Kubernetes cluster, right? Because what I'm focused most for a while now is using Kubernetes cluster as a control plane, right? Now, majority of people, when I say Kubernetes, majority of people think, hey, that's a thingy that runs containers somewhere, which is not at all what Kubernetes is, right? That's just one of the many implementations of Kubernetes. Kubernetes is extensible API with custom resources and controllers and a bunch of other things, which I'm not going to go into right now unless you ask me. You can ask me and then we can go into any direction you want, especially since I don't have really good material prepared. You're warned, right? Does this work? Maybe it does. Maybe it does. Let's see. Okay, that's me. I work for, no, that's not what I wanted. Oh, this clicker doesn't work. There we go. Work for Upbound. I have a Twitter account. I belong to some groups. I have books and podcasts and YouTube. That doesn't matter. What does matter is that I will be talking about observing things from Kubernetes, no matter where those things are running, and assuming that we are using Kubernetes as a control plane. Now, when you run Kubernetes, when you use Kubernetes, you can do many different things, right? You want to run stateless applications or stateful applications, that's easy. I mean, stateful a bit less easy than stateless, but anyways, that's what most of the people do when they start their journey on Kubernetes. If you want to run serverless applications, again, that's why we have Kubernetes, right? That's one of the projects is Knative. There are many other projects that you can use if you want serverless applications. When I say serverless, I mean there are servers, but you don't care about them, right? If you want to manage infrastructure or other stuff, that's where the project I'm mostly focusing comes in, and that's called Crossplane. And if you know Crossplane, use Crossplane, the rest of you be ashamed. Not cool at all. So why do I want to use Kubernetes to manage everything? Again, as a control plane, not a thingy only that runs containers. And the reason is relatively simple. Beyond the obvious ones, that's what Kubernetes was designed for. It was designed to be a control plane and all the shenanigans. It's about cloud native ecosystem, right? Once you adopt Kubernetes, and once you start using it, you discover that basically there are thousands of projects that work all together with each other. As long as those projects are Kubernetes native, meaning that they are designed to leverage Kubernetes primitives, they all work with each other, right? And that's something extremely powerful. That's something that no other project ever had in the past, right? Because in the past, if you use, let's say, Jenkins, then you can do with Jenkins whatever somebody designed to work with Jenkins, right? Jump into Kubernetes, any project works with any other project. It's extremely, extremely powerful, right? Okay. So if you want to do GitOps, you cannot even do GitOps without Kubernetes, right? And if you think that you can, let me know, and we're going to have a very, very long fight. You can use Argo, you can use Argo Flux, you can use Cup Controller, and you can use Rancher Fleet. Those are the only 4 options you have, right? If you want to define policies, who can do what, how can somebody do, and what are the best practices? Again, that's Kubernetes today. In vast majority of cases, we have projects like Caverno, OPA Gatekeeper, DAT3, and since the latest release of Kubernetes 1.26, we even have policies baked into Kubernetes itself, right? Right now, I'm mostly interested in Caverno, but not really important. Now, and all those things I explored in the past, used and worked with them and stuff like that. What I want to focus now is observability, right? What can we do from the observability perspective when using Kubernetes without really going outside of Kubernetes? And to do that, I don't know, does this work? Maybe it doesn't. Anyways, so I'm going to jump straight into the subject. I want to make this as quick as possible so that we can have more time for questions, right? I created a simple dashboard that's part of that 1 hour of work where I'm tracking all the database. I mean, there are pods at the top. Nobody cares about that. You all know that. This is, by the way, Grafana. If you don't know that, then you're in big trouble. Anyways, I created the dashboard where I can track all the databases. I don't care where they're running, right? RDS, Google, Azure, I don't care where they're running, but I'm tracking all the databases over there. There's nothing because I didn't create a database. I will do that in a second. And I created a dashboard over there where I can track all the clusters that I have right now, right? You don't deserve a fully operational production cluster, which I couldn't show you. So this is a demo. That's why there is only one right now. Now, let me show you my application, the one that I'm going to use right now. And if you're familiar with Kubernetes, this should be fairly familiar. I'm using Customize today. Familiar with Customize, hopefully. And over there, I have like Customize base deployment, let's say. I'm going to create Kubernetes deployment, which will create the replica set, which will create pods. I have service, ingress, the cool things that you do, but I want to deploy a stateful application. Stateful application, that means that I need a database for that as well. And remember, I want to do things from Kubernetes exclusively, right? Nothing outside. And to do that, I'm going to also show you another manifest, which is overlays, and I forgot stateful, here it is, Postgres, right? So I'm going to define something I call SQL claim, right? Now, this does not exist. I created it myself using Crossplane, which essentially allows you to create your own custom resource definitions. You define what something is in your organization. And I created something called SQL claim. And through labels, I'm going to say it's going to use Google and it's going to be Postgres and a few parameters, right? So think of me being a developer and somebody else, DevOps, ops person, or database expert, whatever, figured out what should be behind that definition, right? Behind the definition, it could create a bunch of things. I don't care about that right now. What I do care is that I'm going to get my application deployed to Kubernetes. I'm going to create a database in Google Cloud, in this case, and those will be connected together, and automatically application will be talking with that database, right? So what am I going to do? Yes, I'm going to execute kubectl. Namespace is a team, and I want to apply something defined with customize located in customize overlay stateful Google directory, right? So I'm you can see I created the service deployment, horizontal pod autoscaler, ingress, all the standard things, and I created the SQL claim, which is a custom-made resource that will expand itself and create whatever is required in Google. And when I say whatever is required, I mean both the database server, networking, the database inside of that server, schema, all the shenanigans, everything. No, but that's not really the subject of this talk. The subject, by the way, that I'm using Crossplane for that. There we go. Anyways, the subject of this talk is how I can observe the resources that were managed by Kubernetes, right? And there are quite a few ways I can do that. One way I can do that is use whichever, I mean, not one, many ways I can do that is simply using whichever tools you're familiar with in Kubernetes. I assume that most of you using Kubernetes are either using kubectl. If you're doing that, great. Maybe you're using, maybe you get depressed when you see black terminal and then you're using something like Lens. Not so great. I'm using it actually today for the first time in the last 3 years, so bear with me. Anyways, I can observe what's happening in my cluster, right? I can say, hey, those are the pods running their deployments, the standard stuff. But what is interesting here is that I can say, hey, what are all the clusters that are managed by my Kubernetes? And this is too small, right? You need to complain. There's a cluster that you saw before in Grafana. And here's the database claim that I just created, right? You can see the status is already there. You can know what's going on in 2 ways. First is to see the statuses. It's synchronized, but it is not yet ready, meaning it is working there. It takes 5 minutes, give or take. Or you can go through the events and see all the details of everything that is going on, right? Because a Kubernetes controller right now is communicating with Google Cloud in this case. And that communication is stored as events in Kubernetes, and you can see what's going on. I'm going to get to that later, right? Or you can say, instead of using Lens, which is horrible, don't say that, but you can use something like Prometheus, right? Everybody's familiar with Prometheus, hopefully. I'm not going to go directly to Prometheus. I'm going to go to Grafana. And I can copy this because it makes me look like I know what I'm doing. Let's say, hey, by the way, that same dashboard you saw before, the database status was empty. Now you can see that actually it automatically detected the database. It knows the status, it knows everything about it, and right now it is not operational, right? I can go to explore and do the typical things that you would normally do with Prometheus, query it, except that now you're querying Prometheus with data gathered from outside of your cluster, right? Like, hey, give me all the custom resources that are tracked right now with kubestat metrics, and group them by the type of the resource that you have right now. And you can see right now in my cluster, in my control plane, there is a cluster being managed. There is a node pool, there is database instance, cluster claim, SQL claim, some releases, some objects are being created, the database is being created, and the user, right? Maybe more. Now I will not bother you through this, right? You can do the typical Prometheus query. You have the metrics there. You can do whatever you want to do with it. Now, to make all that work, I in the control plane, in the main cluster, I install Grafana, I install Prometheus, that's logical. Now, when you install Prometheus operator, by default, it comes with something that many people are still not using, but it's extremely awesome. It's called kube state metrics, right? So it is exposing the state of all Kubernetes resources. Unfortunately, it is not really exposing the state of all the resources, but only those that are come out of the box when you create Kubernetes. You need to tell it what else you want to monitor. And I'm doing that over here, right? I'm saying, hey, apart from whatever is being monitored by default, monitor something called the SQL claim, monitor something that is called, those are the metrics, called cluster claim. Those are my custom resources. And then there are some resources that come out of the box in Crossplane, like node pool, and so on and so forth, right? You just need to give it a list of the additional resources you want to observe. And from there on, you will have in Prometheus all the events that are being generated by those resources. You need to specify what exactly you want to monitor. Like in this case, I'm saying, hey, I want to monitor the status of those resources, and those are the possible variations of that status and stuff like that, right? Now, this is painful. This is a result of 1 hour, but most likely, if I have time, I will create a Kubernetes controller that will do that automatically and so on and so forth. So more work to be done. And that's about it. Once we do that, you can create dashboards or do whatever you want to do, just as you would do with any other type of metric coming from into Prometheus and being gathered from Grafana. In this case, like that dashboard. Again, all part of that 1 hour of work. Now, what else? Another interesting tool that I found while I was investigating is I forgot the name. I will remember probably. Yeah, Kubernetes events logger, right? Because Prometheus gives you metrics which are great for detecting issues, not necessarily great for debugging. That once you know what's going on, where the problem is, you probably want to go and see the details and so on and so forth. That's not what Prometheus is good for. But then Loki is right. Loki already comes and gathers all the output from all the containers running in my cluster. And all I had to do is install Kubernetes event logger. I can give you the link later. Essentially, what it does is that it gets all the events from all the resources in a cluster and outputs them to std out. And from there on, Prometheus gets them as any other logs and puts them in Loki, and then you can do whatever you want to do. And what I want to do is, for example, if I go to explore, come on. If I go to explore, I can say, let's be dumb and say, I want to select, huh? Oh, that's such a great suggestion. Thank you. You just saved me a lot of trouble. Application, where is it? Event logger. And I'm not sure I noticed something. Yeah, let's filter for, doesn't matter. Let's not filter, right? Run the query. Here you get all the events, everything happening in a cluster, but actually cluster, all the events happening outside of the cluster being gathered in Kubernetes resources and then exported to Loki. If this makes you dizzy because it's too much information, you can just say, hey, I want only the messages. And then you see what's going on. Too small again. What's going on with anything essentially running anywhere. Again, if you like Lens, if you don't like Grafana, which you should, you can just see the same thing. Where is it? Events, same thing, right? Different ways to represent different statuses of different Kubernetes resources. And that's my extremely short talk, as much as I could gather in an hour. And now we have unknown amount of time for you to ask me any questions, and then I can pretend that I know the answer. Huh? Yes? Go. Podéis preguntar en castellano, si este es el problema. A ver. Puedes preguntar lo que quieras, no importa si es relacionado con la charla o no.
Okay,
Yo reservo
I have
derecho
a
de
list.
no responder.
I have a list. Two actually. Dos horas. Mira, te explico un poco mi caso. En la empresa que trabajo, estamos intentando implementar Crossplane y tenemos unos problemas de cómo monitorar, es uno de ellos, y otro es cómo manejar los compositions, o sea, uno de los problemas es que no hay environment en el IDE, por ejemplo, para validar. Sé que hay que hay un linter de Crossplane por ahí, pero lo que nos cuesta es cómo generamos los claims o sea, cómo templatizamos los claims y los compositions iniciales, cómo hacemos una pipeline hasta el despliegue de los packages. No sé si tienes
Sí.
tiempo de hacerlo.
Si he entendido bien, una de las preguntas es cómo simplificar la manera de escribir
El dev
compositions
experience, yes.
y luego cómo publicarlos.
Yeah.
Me he olvidado en qué idioma has preguntado, en castellano o en inglés. Vale,
Portugués.
portugués, vale, este no conozco. No, este es como castellano, pero con patata dentro de tu boca, ¿no?
Exacto.
Vale, no tengo patata conmigo.
Vale.
Um,
Castellano, entonces.
Sí, de manera de escribir compositions pueden ser largos, porque, por ejemplo, míos que yo tengo para AWS fácilmente pueden llegar a más de 1000 líneas, a veces 5 dígitos. Ahora, no tengo respuesta concreta por parte de Crossplane cómo hacerlo mejor, porque este es uno de los temas que estamos explorando ahora mismo. Todavía no tenemos respuesta. Y parte de razón por qué están complicados es que no queremos introducir un otro DSL que parece mejor tener bucles o condicionales, pero cualquier proyecto que yo conozco que ha introducido DSL se ha convertido en una ¿puedo decir mierda? No, lo he dicho. Pero sí, estamos mirando cómo hacerlo. Mientras tanto, lo que yo, por ejemplo, hago esto es el poder de hacer cosas de Kubernetes. Puedes escribirlos usando Helm o Customize o cualquier cosa. Mi preferencia personal es CDKs. Que lo bueno de CDKs es que te permite decirle, vale, esto es el CRD. No importa si estamos hablando de Crossplane o de Argo CD o cualquier. Esto es el CRD, descárgalo y conviértelo a librería, en mi caso de Go, puede ser Python o lo que sea, a una librería. Y a partir de allí, es pim pam, simplemente tengo autocomplete, tengo validación, linting, todo, que tengo cualquier otra librería de lenguaje que estoy usando. Luego, segunda pregunta era cómo
validas porque claro, o sea, una vez tienes una template tú o un DSL por encima, es muy fácil que generes cambios que no quieras, ¿no?
hay que
Entonces,
testarlo.
claro, entonces como, no sé si un div usáis en el final del estado o...
Internamente, nosotros estamos usando Qtl, KUTTL.
Sí.
No hay nada de momento como dentro de Crossplane.
Claro, el problema que tenemos con Qtl es que si haces recursos que dependen de otros, como puede ser un node pool, entonces, o sea, tengo que hacer el full integration. No puedo solo ver el estado en el Kubernetes porque depende del resultado de la API del CSP.
Sí, pero no tenemos nada
Mejor que eso.
mejor hoy.
Entonces sería compositions muy pequeñitas para testearla más fácilmente.
O depende. Yo, por ejemplo, míos son muy grandes. Depende del punto de vista. De un punto de vista, testar compositions puede ser complicado o fácil según el tamaño, ¿no? Pero de otro punto de vista, la ventaja que tienes es que una vez lo tienes testeado, 1, 2, 100 o 1000 instancias de básicamente tú estás actuando como proveedor de servicio.
Ya.
Es complicado testarlo, pero una vez testado, tú puedes, asumiendo que has testado bien, quiere decir, vale, ahora adelante. Cualquiera en mi empresa, lo que sea, puede crear recursos basados en esta composition.
Claro.
Y sabemos que funciona. No te estoy dando una respuesta clara, pero no tenemos de momento nada dentro de Crossplane.
Sí, no, es que esa es la discusión que tenemos internamente. O sea, cómo montamos esta pipeline que tiene que ser secuencial, pero tienes que hacer toda la integración, desplegar el recurso en el cloud. O sea, tarda un poco, pero
Sí.
Bueno, voy a parar.
Ahora
porque
depende
sí,
también de qué cloud. Quiero decir,
Claro,
en Google lo que tarda 5 minutos, en AWS tarda media hora.
en Azure 2 días.
Sí, allí no puedo ayudar. Sí.
Sí. Bueno, gracias.
Adelante. Por mí,
Sorry, I don't speak Spanish, so I will go in English.
no problem because my accent is unbearable in Spanish.
Okay. Also, I'm not an SRE, so maybe my question would be a silly one. But how different is Crossplane from other thing like Terraform or CloudFormation? Just to understand.
So I can give. I'm going to give you a couple of different answers, and you pick the one that makes more sense for you. One difference between CLI-based tools like Terraform and not exclusive to Terraform is that, well, it is equivalent. So imagine if it would be an application and you would be managing and deploying that application by SSHing into something and executing some commands, right? And then imagine that same application being in Kubernetes or other type of managed services, where you say, I'm not telling you anymore what to do and when to do. I'm giving you full responsibility to manage that something for me, right? So if I execute Terraform apply, something will happen, whatever that something is, right? And then my whole data center might go down, or my server might go down, or my VPC might stop working, or something might happen, and nothing will happen. Nothing will correct that state until the next time, until I get the notification on Slack. Somebody calls, I go there and check what's going on, and I re-execute Terraform apply to get back to the state where I was before, right? Now, what Crossplane does is the same thing what Kubernetes, right? It is making sure that the state that is, I don't know what's going on here, is maintained all the time, right? Just like when you have an application Kubernetes, a pod goes down, Kubernetes brings it back up, right? Same thing with any type of Kubernetes resources. And if those resources happen to be Crossplane, same thing. Database is down, bring it back up, do whatever needs to be done, and then you sleep well at night. Another problem with other tools is that they do not have an API. And no sane person would create a tool without an API today, right? So you cannot query, you cannot say, hey, what are all the nodes I have right now in my system? Or what are all the nodes that belong to the team A or team B? And how about VPCs? And you cannot, there is no API, you cannot query it, you cannot do stuff with it, right? I can give you more answers but
Okay, thanks.
it's simply, Actually, I'm going to give you more, right? Without giving you the answer, really. Whatever are the reasons somebody would use Kubernetes to manage applications, whatever those reasons are, those same reasons and same logic applies to infrastructure and services. Whatever the reasons are, whatever somebody put on a list, I want to go from Docker to Kubernetes or from VMs to Kubernetes from my application, you can just copy and paste that list and you get arguments for using it. Anybody else? I don't know how much time I have. I don't know whether I'm over time, under time. 5 minutes. You have 5 minutes to ask questions. Puede ser en castellano. Si estáis. Anybody? Nobody? Given once? Given twice? Sure? No? Okay. Then let's bring in the next one.
Hola, hola. Okay. So we agree in English, right? Better. Okay, no problem. First of all, despite what the Zoom said, I'm not Victor. I'm Pablo. Thank you very much for Victor for lending me his notebook because I have some connectivity problem. So my name is Pablo Chesina. I'm the lead of the Chaos Engineering Group in KCs. KCs is a group within Grafana, which is dedicated to testing. Okay. It's curious because this query is really small. I was just mentioning Victor before that the way I get into this project was because I was watching a video of the cases team with Victor talking about chaos engineering. And I got interested in cases and I started working with the cases folk about chaos engineering. And I'm now here and I'm here with Victor. So it's really amazing how community actually works. It's mind blowing and said, whoa, you know? So what we're talking about is this project. This is a project that we launched in cases some month ago for using cases for chaos testing, specifically in targeting microservice and Kubernetes environments. Okay. So make it work. Yep. Nope. Victor. Oh, you know how to go page by page. Okay, that's going to be painful. Don't worry. Don't worry. No, yeah, 100% in it. Just, you know, no worry.
Suffering time.
Yeah. That will be, yeah. So the topics, basically, the idea of this, we're talking about the chaos testing, which is a concept which is part of the chaos engineering as a discipline. How to do chaos testing with cases. I will do a demo, which kind of walk through to an example. We're not going to do a live demo. One of the reasons is that when I learned that Victor was here, I said, okay, I know there's no way. I'm not going to do that. This guy has been doing live demo for a decade, and so no. It's more like walk through an example, and at the end we'll have some time for question and also for picture. So let's start. Let's start for something that is obvious in some way, but it's important to set the context. It's like why achieving reliability in modern application is so hard. There are many reasons. The first is because we, as an industry, we have adopted a kind of the de facto architecture, which is basically using microservice architecture deployed on around cloud native infrastructure. That basically means that we are creating applications that have increased the complexity in terms of the number of components that we have and how they are interconnected. to each other. Okay, and this complexity, and we're doing it for good reason. I mean, the criticism it brings a lot of benefits like more flexibility in the way you deploy this application, how you scale them, etc. But the main consequence of that is that this complexity at some points are being beyond the ability of the engineers to really predict how this application will behave under certain circumstances. What I mean is that when you deploy a microservice architecture in Kubernetes, and then you have this Kubernetes running in some cloud infrastructure, so if you have a failure in a node, the infrastructure is going to try to recover, and Kubernetes is going to try to recover, and your deployment tries to recover, and then you start having pods going up and down, and then probably you are lacking resources, you start evicting some pods, and then, oh, I'm evicting pods, so I need another node, and with migrating pod to another node. And all this complexity is really hard to predict what is going to happen, really. Okay? And therefore, you cannot really predict exactly how the application is going to fail. Here is something that's important because in all this process, it's asynchronous in nature. And when you have synchronicity, and then things like the delays, how this happens exactly in the timing may be important. Okay, so result, it's really hard to reason about how systems fail. And generally, the failure, when you do a post-incident analysis, and I was working as an SRE for years, then you realize that at the end of many of these failures or incidents, you can see that, for instance, you find that the application were not able to cope with some kind of failures because, for instance, they were not retrying, or were retrying too much, or too fast, or too slow, or not long enough. So it's really hard to predict how they fail, but also, even if you try to test your application for that kind of failure, it's hard because how do you reproduce that? That's precise sequence of events and the consequences. That's the kind of the situation you as a developer are. Don't worry, there is hope. So the first reaction to the community or the industry was adopting the idea of chaos engineering. You say, okay, if we cannot predict exactly how application behave, let's embrace chaos. Let's just inject failures into the infrastructure, induce those failures on purpose. So basically, you are training your engineers to get used to incidents so they can no longer waiting for an incident to happen to introduce some remediation. It's like you assume it's going to happen. You see every day and you get used to that. You are kind of battle testing this point. However, and this is a good idea. I mean, in principle, something that is important to set here is like, we agree that this is a great idea. But for who? Well, that's the problem. First, doing that has a risk. You're introducing failures on purpose on your live application. And by the way, you're doing your real production system because if you could really reproduce all that in another environment, you could do testing there. So the problem is that you cannot really reproduce it. And the moment that you change the size of the environment, you change that. So you need to do in the real thing. So you are introducing failures there on purpose. And that requires some courage and also some practice to get there. So how do you get there? Essentially, the problem, like the people that don't like to go to the gym because they are on shape and they don't want to go. So how do you get to shape, to the minimal shape to go to the gym, you know, and not be embarrassed yourself in the gym? So it's like this situation. How do you get into chaos engineering? You don't do anything before. How do you arrive to a minimal shape to really dare to do that? That's a problem. The second one is, as I said before, the real problem is that the actual situation is hard to reproduce by definition. I remember as an SRE, after an incident, we tried to reproduce the incident, and it was impossible because the infrastructure was outsmarting us. We were trying to kill something, it was recovering faster than we could actually run the test. Well, what the hell? Why you didn't do that the first time? Why you are, so now they were doing what we expected, but it's really, really complicated. You try, I really, it's a good exercise. You try to reproduce an incident, a complex one, and you figure out, you realize that it's really how many different pieces are intervening there and how complicated are these different recovery loops behave. So the results are hard to reproduce. So it's the results are hard to reproduce. How do you train for that? It's like the same, similar, you're going to the gym and you are randomly do something different every day, you are not really training. You're just getting some random exercise, so you're not really getting in shape for anything. And the last problem I see is like chaos engineering for doing this kind of experiment, you require some kind of specialized tools that have been developed for this purpose. And these tools are great, except that they are being designed for and by and for SREs and developers. You really need some kind of understanding of the infrastructure to really use it, because you are really actually mangling with the infrastructure. So for the average developer that either doesn't have the knowledge, or if they have the knowledge, it's not their business, this kind of tool maybe brings some complexity, additional complexity, if they really want to test their application using chaos engineering. Okay, so is there any alternative to this situation? We want to really be able to test application before things happens, but we have all these blockers, so to speak. Well, this is interesting idea that come from by the way, two folks that were in Netflix when they were developing the chaos engineering practice and the chaos monkey, that they said that from the perspective of distributed system, any interesting reliability test or experiment can be reproduced if you can actually manage to control the latency and the errors that you are returning or requests between the system. Because actually this is what happened. When you have a distributed system, where you have this component that talks to each other using some kind of protocol. So you can control actually how this protocol behave from the perspective of the one that's been affected. You can reproduce the same situation. Let me explain one example. It's actually how I landed in this project. Is we have an incident, and there was a series of conditions that made one database to get especially slow. And by being slow, the service that we use in the database start having some specific problem. First, the latency of the response time was rising. At some point, it was using the connection for too long, so we get into the problem with the connection will start dropping. But that is what's happening, and the root cause. As an SRE was my main business to try to figure out why this happened. But from the perspective of the service that is using this another, the service, the consuming the service, what this is observing is only that the latency is changing, is rising. Eventually, it's getting some errors. What is happening inside the database? If the database is being overloaded because of CPU consumption or for memory, actually, you cannot really see that. You only see the actual effects in the latency and the response. And that's the key of this idea. It's shifting the focus from reproducing the root cause, which is basically what the chaos engineering has been doing, to reproducing the effect of this. And this is called fault injection. And fault injection has been around for a long time, and actually a very established practice within some communities like automotive. They do a lot of this, okay? Basically, you on purpose simulate some failures. The failure can be electrical failures. For instance, I work in a startup that we were using Internet of Things stuff, and one of the things we do was you actually make some electrical discharge on the equipment to see what happens. You know, you reproduce condition that you could find. And basically, you want to uncover if any deficiency in the way this system behaves under this specific fault. Now, you can ask, okay, hold on. You were telling me before that the main issue that we have here is the complexity of the system and the interplay between multiple components and multiple elements in the infrastructure and the application. And now you're telling me that if I just try to test my application, injected some specific faults, that works. Okay, this is a trick. It works or help to improve the reliability because, and this is an interesting study of many large-scale distributed systems, even infrastructure systems, that they found that the vast majority of the incidents, the catastrophic incidents, the root cause of those incidents was that the error recovery logic was effective. It was not really a really complex logic that was failing. Just you having this error, like for instance, the edge latency is increasing, or you are getting some error that you are not expecting. And this is what actually triggers the actual incident. And actually, more interestingly, like in a large proportion of these cases, this kind of flow in the logic of error recovery logic could be uncovered just by testing, isolate. That you don't need to really reproduce all the complexities. You say, okay, if I have this kind of incident that will come into a much longer latency or that kind of errors, let me test my application with that specific situation and see what happens. And then you will uncover a lot of errors in your logic. What kind of logic errors? Well, this is really funny. In more than a third of these cases, the error handling logic was actually 1 or 3 cases. It overreacted, like, oh, error, panic. And so you basically abort your system, okay? People is laughing because, you know, you feel absurd. I was. Well, looking at this, oh, yeah, I have done that. The second case is just empty of block print error. You're doing nothing with the error. You're not handling it. Or the error handling logic have a comment like to do or fix it. I mean, I'm talking about here a code that was actually used in production by a large organization like Google. That is not, you know, joke. It's really funny to see that you can find that kind of error. So what all this is telling us is that there's a lot of room for improvement in the reliability of your application if you simply test your error recovery logic under very specific circumstances. You don't need to reproduce complex situations. You don't need to reproduce complex failures. You just to take your application and say, I will inject this failure and see what happens, which is basically a test. And that's why we're calling it chaos testing instead of the chaos engineering experiments that has the purpose of exploring and learning how your system fails. Here, the idea is when you learn that, either because you have a real incident or because you are experimenting and learning and you know how your application failed, then you come and you test your application on that specific condition, this specific fault, and you validate if you are handling it properly. I am retrying. How am I retrying? What is the logic? What's happening if I change the latency? What's happening if I increase the error rate? How my application is behaving in that circumstance? That's basically what we do with the testing. So we're basically focused on that. What basically means that we are shifting less this from the production to development. Because for doing this, you can do it even in your local development environment. You don't need a complex environment. You only need the ability to inject failures in a specific points, and we'll later explain how. But seeing this as a part of a more larger practice, the idea here is that once you get to that, once you start testing your application and you start getting more confident that you are doing things right, then you can go and now start experimenting in production. Because now you have a more confidence in your ability to actually handle, at least on a basic level. And by experimenting, and that is important because your application is changing, you're introducing new services, you are changing your infrastructure, you will uncover new failures, and then you go back to test them and improve. So this is a continuous process. So basically, how chaos testing help developers? Well, it will help you basically to uncover any deficiency in your error handling logic. That's it. It's giving you the confidence that you can actually handle them, and then you can test your application on the more sophisticated use cases. Also, as I said before, if you see the post-incident report of any large outage in Amazon, Google, you will see that a lot of those catastrophic incidents, the root cause was because they were, like, for instance, overreacting to the failure, retrying too aggressively. So you can try that. You can really see and fine tune and say, okay, how is my logic for retrying? I'm retrying enough and not trying too much. How can I adapt my application to really prevent that kind of situation? You can test that in your test environment. And the same can apply also for DevOps and SRE. Even when I'm making the focus on developers, they can also try some other interesting things. Like I discovered by mistake, it's like I was injecting some failures in my pod during preparing the demo, and they say, what happened upon 100% error rate? All the requests were failed. But obviously that my pod was killed because the health check validation of the pod was being also returning 500 and my infrastructure were killing it. So I realized, oh, this is funny because I can really see how the infrastructure behave if my health endpoint is too slow or is failing. Am I really doing my health check properly? You see? It's something that I found that was not intended use case. I just found it because I killed my own pod. I said, what's happening here? So you see, you can apply the same principles not only for developers, but also for SREs and for DevOps. So that's the theory. Let's put that in action. We're using a demo application that is called the SOC Shop. It's an application that was developed many years ago. This is really interesting because it's actually a full functional e-commerce site that have a catalog of product. You can go there, you can browse, you can buy. It's really interesting. It's a microservice architecture. Different microservices are developed in different languages. They communicate to each other using HTTP, and you can deploy that in Kubernetes. We are focusing on the front-end service. The front-end service has two roles. It's basically back the actual front-end, which is a web page, but also it acts like a kind of API gateway. You can access any other service by means of the front-end service. And let's imagine a fictitious post-incident review. So something happened in the catalog service. The catalog service, the database was overloaded because someone was running very long queries. Because of that, the latency started growing. And then because of that, also some of the connection will be dropping. And then you were having some 500 errors when accessing this service. This is a catalog service. The team that is in charge of the microservice need to figure out what happened, what the root cause. But meanwhile, the fault on the front-end service, I'm wondering, okay, if this happens, how will that affect us? Are we really managing this error? I mean, we access the catalog. What's happened with the kind of error? Let's see how we can do this. We now are in part of the front-end team. What could we do? Well, we can start using cases, which is an open source tool for testing. The tool was initially developed with the focus on load testing. Probably some of you know from that use case. But over the time, it has been evolved to be a full reliability testing tool. You can do all other kind of tests like chaos testing, but also other kind of tests. And basically, in cases, the tests are implemented as JavaScript scripts. Okay, it's what we call test as code. Typically, this is typical cases test. You have the test, you run in cases, and you inject some load in a system under test. And the cases generate some metrics. Okay. A few key concepts. We're not really going into much detail on that, but it's important to understand the example. Like in KC, the tests are implemented in functions. You have functions that simulate some flow, some use case or user journey. Okay. As part of that test, you can have some check. Like if you are doing this, you can validate that you are getting actually the result you're expecting. You define some scenarios that basically define the load you are executing, like how many virtual users you are running, how many requests you are making, how fast you are making, like 1 request per second, for how long. It's basically your scenario. So you can actually have the same logic and test it on the different scenarios, meaning on the different workloads. Okay, that's also really flexible. And then you can also define thresholds. Thresholds are defined, for instance, in terms of the checks. Like you want to validate some condition on your test, and you define like if more than 5% of the requests fail, my test fail, which is very close to the idea of an SLO. In our case, what we're going to do is to use this tool for creating this kind of test. So basically, we're creating a test in cases. We're injecting some load in the front-end service. This request that we're injecting in the front-end service is basically making a request to the catalog service. Okay. Remember that the idea is you want to check how the front-end service behave if there are errors. But we start with this test, no error, just simply running the test. This is the code, mostly. There are some boilerplate code, but this is basically it. Don't worry, this is not, we're only going to the most important part. Basically, we have this function that basically makes a request to the front-end service, requesting a specific product, details of a specific product. That is. And we check that we are getting an error or not in the response. Okay, this is typical API that when you make a request, it will always return at 200, but then you need to figure out if this 100 is actually an error or not. And we are defining, we're defining here our threshold. We say, okay, if the rate is, in this case, if the check is less than 90% of the check are unsuccessful, then we consider that they'll fail. We're allowing a 3% of requests to fail. For all that's fine. It's our SLO. And then we are defining the scenario where we're submitting a certain load at 20 requests per second for 1 minute. It's basically what we're doing, simulating a certain number of virtual users. That's really not that important. So we run this test, and we get this result. This is a summary of the cases when you run it. Okay, you basically see that everything is fine. We run it, we have no errors to check. I mean, we made all these requests, actually the number of requests is somewhere there, and more than 1,000 requests, no errors. And we see that the response time, the 95% percentile of the response time is around 8 milliseconds. So that is a baseline, that's how it works, okay? But that's not what we want. We wanted to inject some chaos here. So what we're going to do is the same test. While we're applying the load to the front-end test, we're going to inject failures in the request or the response of the request to the catalog. And this is really important. And what's something I find it's really cool is you are exercising one service, but you are affecting one dependency. Or you could affect a dependency over the dependency. You are free to decide where you want to inject. So here we are decoupling what you test and where you injected the faults. So you can actually see is there any kind of cascade effect in this, okay? And for doing so, we're using an extension of cases, which is called the KC disruptor. That's the project has been leading. And basically it allows this, injecting fails in a system under test. I'm not going to go into much detail, but basically the idea of how it works is that when you define a target for the fault injection, and this disruptor will inject an agent in those target. This case, it is bot that, for instance, back a service in Kubernetes, and is this agent, which is basically a sidecar container, is the one who is going to make the fault injection. That's the overall idea. And later I will show you some links you are more interested in learning how it actually works. There are some documentation in the front. It requires a minimum of Kubernetes 1.23 because this facility of injecting that kind of sidecar container was only available after this version. Before it was alpha, and by default is not available in most clusters. And for in the case of this container that you're injecting, this agent need to actually mingle with the traffic. So they need some minimum privileges to do that. Besides that, you only need access to the cluster to actually run this. Okay. So let's see what we need to do in the test. The test, remember, was the code now is like a gray out, is the original test. We are only adding these two elements. First is a function that is the one that actually is injecting defaults. The function basically defines a fault in terms of something that is familiar. Is I want to inject this fault, which is an average delay in the response for 100 milliseconds, and 10% of the requests will fail with a 500. That's what I want to simulate. And then you decide which is the target. And I want to inject this in the requests that are being served by this service, the catalog service. And then you say, and I want to inject this for this time. In this case, 60 seconds, which is the duration of the whole test. And you define, that's something which is very specific of the way cases work. We basically define a scenario. So you have the loaded scenario, which is the base one, and now you define a chaos scenario, which basically injecting failures while the other one is running. Okay, so basically you're separating these two. And actually, you look at the demo of the code using some environment variables. I can run exactly the same test with and without failures, so you can compare. It's pretty cool. We now run it, and we get this response. Oh, okay. You cannot see it, but this red there is because there are a lot of failures. It's actually, the error rate is, oh, it's now getting focused. The error rate is around 11%. This is a slide open. So we injected 10%, and we're getting actually that same number of errors in the front end. So let me clarify what is happening here because it's important. It's, sorry for this. We are actually, the test is making requests to the front end. We are injecting failures in the catalog, and we are checking what's happening in the front end. And what we are seeing is that almost every failure in the catalog is being reflected as a failure in the front end. What is said? That probably, if you look at this code, there is a big to-do or fix me in that error handling code. Actually, I look at this code, and what happened is there is nothing there. It's absolutely absent. There is no recovery whatsoever. So basically, you're uncovering and say, what the hell? I mean, if you make 10%, you don't expect to have 10% of failure. You expect a minimum the application try to recover somehow. And we're uncovering that kind of deficiency with this simple test. But what is interesting is that not only that, is that we can now, using this, you can start implementing recovery. Okay, let's make a retry on these failures. And you try, and you execute the same test with different error rates, and you can see how different error rates change your behavior until you get something which is acceptable. In that case, remember, we define an SLO of 97%. So that's the flexibility that you have. And all this actually running in my own machine using a test cluster. I don't really need a real cluster because I'm not really reproducing the root code. I'm just injecting the failure on will or at will during my test. And that is what makes this approach so powerful. So basically, this example puts all the principles of yep, thank you. Basically, the principles that we develop with this project or this approach. I don't know if you are any longer seeing. Oh, I'm sorry because I'm disconnected from the network. You are not really seeing what I'm talking about. Allow me some moments. Sorry for this minor glitch. Yep. I have a technical issue here. I would appreciate your assistance. Yeah, I know I'm connected there, but this. Yeah, you always network connection fail. And I guess I was kicked out. Es un poco complicado. ¿Cuál era el password? ¿Cuál era la? No, ¿cuál era? ¿Era esta? Luego Yellow Park. ¿Ah? No, es que claro, yo voy a tener mismos problemas. Si no me puedo conectar. Sí, no sé en qué momento está conectado. Pero no me he dado cuenta. Ya, lo que pasa es que había una transparente que quedaba. Mira tú. Creo que
pasa nada, chicos. Sí, no, mira. Sí,
documents are super resistant. Well,
Okay, sorry, we're back. Okay, we are back. Fortunately, we are almost finishing, but I want to show you a couple of things. Oh. What is that? What I did? Inbox? Yeah. Okay. We're almost on the end, so it was just to recap a little bit what we did. We were basically saying how this kind of test help the developer, in the case, the current team, how can use this kind of test to improve the reliability of the resilience of the application by testing it on the different failure conditions. And the main idea here is that the idea we wanted to make that the chaos testing, basically the main concept is that you can control or you can test your application on the very specific failure conditions, okay, in a way that you can really do it in a predictable way. Remember, one of the problems of the chaos engineering is that the unpredictability of the environment, but also the predictability when you make an experiment. Actually, that's what it's called chaos engineering. It's because you can really predict what's going to happen, and you're doing that on purpose. But here, as a test, when you want to really fix that, you really want to be able to reproduce in a very reliable way. If I run this test 10 times, I usually get more or less exactly the same result. So I can really test. I can train my application because I can predict how it's going to happen. And then what I need to check is how my application is behaving under that specific situation. So the brief, the too long didn't read of all this talk is, yeah, I mean, you probably don't need to kill that part. If you are running code experiment and you say, okay, I need to test the reliability of my application, the first thing that many people thought is, I will kill some random part. You don't really need to. Probably you don't even want to do that. And if you do it, it's not sure what you're learning from that experiment. And if you learn something, it's not necessarily true that you're going to fix what you learn, what you uncover. Okay? So you basically should improve much more your application, your reliability application, if you are sure that you go to your code and you look into your fix me and you to do and you do them and you fix them, and you are sure that you are really handling your error. And that's basically the concept of chaos testing. This is the project, and I'm leading the XDS Disruptor. It's an extension to KCs. You will see these links, the documentation, and some examples. Actually, this same example is in the documentation. If you find this project interesting, you find these ideas interesting, we are hiring a Golang developer for this project to work with me. And also, we are hiring DevOps for our team, running in the backend. And thank you very much. If you have questions.
Hey, in a previous slide, where you were setting up the whole thing, there was a line talking about metrics. What are those metrics? What are they for the result of the thing?
Sorry, which one? In this one?
No. About in the diagrams, it was like a line.
Oh,
saying
the metric.
metrics.
The metric is basically this one. If you are running locally, you basically get this summary. But one of the nice things of cases is you can send the same metrics of the test to, for instance, Grafana, and you can have a dashboard. The reason I'm not showing that, and actually there's a version of this same test using that, is because if you are doing testing, you don't really want to go and look in the dashboard if the test failed. So basically the idea is that you define a threshold and you run the test, either the test fail or pass. If it passes, it's because you are fulfilling your threshold. So I'm more showing the idea of test automation, where you can basically, with a few line of code, actually not even line of code, you can just configure and send in all the output to Grafana. And you can have a dashboard with the same metrics, which is basically all this information you are having here for the request, the duration, the number of checks, the failures, all that.
And perhaps also in Prometheus, you can store those metrics.
But
in-
actually, yes, actually the output is for Prometheus, and then you can use Grafana for yeah.
All right.
Actually, yeah.
Thanks.
There was another question over there. Yeah.
Thank you. So my name is Roberto, and although I currently work as an engineer, I write agents for observability. I do have some bit of background in lower level stuff. So I'm curious about how K6 or the disruptor extension manages to inject these faults. Like, is this using, you mentioned there is a sidecar NetAdmin involved. So is it doing some trickery with NetFilter, injecting IP table rules, or is it doing
All that.
all that?
Okay. Yeah, I mean, basically what you're doing is we're injecting this agent, and at this point, as a disclaimer, this is a very early stage of the project. So basically what we did is what we found, looked at what are the more common failures that people need to check, and you basically are focused on injecting failures in HTTP requests, and we are now working on supporting gRPC, because a lot of services are moving to gRPC, but gRPC is a little more complicated, but the principle is the same. Basically, we inject the agent, and then we rewrite using IP table, we rewrite the traffic. So now we have the agent is a proxy, just basically getting all the traffic, and based on the configuration is doing either introducing some delays, artificial delays, or just injecting a fault. One nice thing is that you can like select, not only you can set the error code, you can even return everybody, because in this case, I didn't show that here because the text was too big for fitting, but basically there is a configuration that you set the JSON that you want to return, because that's important. Otherwise, the front end will not recognize the answer. And we are now working on making that you can actually select a specific path that you want to inject the failure, because sometimes, like in this case, you may have multiple. No, I don't only want this specific path to have the delay, because this is going to a different database. So it's not really kind of, I would say, realistic that all the requests to all the endpoint had the same delay. Sometimes that is kind of okay. That's not necessarily how it works. So we're like adding some additional functionality, but the main concept is that the agent is like a proxy. And the nice thing is that when the full injection ends, we disconnect. I mean, rewrite again the traffic, and then we're no longer be part of that. So only during the test, it's happened. What is important, among other things, because we also aim to be able to run those in shared infrastructure. Given the state of the project, we don't recommend to do it in production, not yet. But for instance, in staging. And what is the problem? Many you are like running, I want to run a chaos experiment in staging, that you basically bring all the cluster down, and you are 30 developers. You are not going to be you're not going to get any good feedback from your peers. But here you just inject that for 1 minute, and then you disconnect, and this is done. And the rest of the cluster is running. So for instance, I'm running in my machine, the same cluster has been running for a week. I'm running this like every hour or so, making changes and try and stop. During the duration, the rest of the time is working just fine. So that's basically the principle.
Mm-hmm. Cool, thanks. So if you don't mind a follow-up, this proxy that you are using, your redirect tables.
Okay, about the proxy, it's a very early stage. It's really simple. It's not super high performance. Again, this is for testing. Mm-hmm. It's different. This is not going to be a service mesh. So if you are testing this environment, here the nice thing is that, for instance, if you want to simulate some of these events or some kind of situation, traditionally, if you want to increase the database response time or delay, you need to overload the database. So you need a lot of traffic to overload And once you have it overloaded, you test. Here you put one request, already you have the delay. So in reality, it's not that you want to improve it, but you don't really need a high performance proxy because you are just trapping some specific request and injecting a failure there. Okay. That said, part of the thing that why we're looking for additional engineering power is because we want to make it more robust and being able to run that actually in production over very high loads. And that's the goal of the project in no long. Any other question?
Thanks. I have many questions, not technical. You may answer now, or maybe can discuss later on. One of the question is, who is implementing those tests? Are the developers or is it SRE team? Anyone else?
That's the beauty of this. That should be the developer. Because if you remember this fictitious incident, actually it's fictitious just because I changed the name of the person involved to protect the innocent. But actually, it actually reproduced an actual incident I had at SRE, and changing the name of the service is exactly that. Is you have the incident, the SREs come, we found this problem, and then the developers of the application were the ones that say, oh, crap, I mean, our connection pool handling is really crap. And what you do next? It's not the SRE work to do that. We were working on why the database didn't recover, blah, blah, because some more complicated stuff. But the developer has in hand the hot potato of, okay, I know that my connection pool is crap. How do I test it? This way. So the goal of this is that the developers can test their application under the specific, because they don't need anymore any infrastructure or whatever, just knowing how this incident is perceived, what kind of errors or alteration of the latency happen, reproduce it and test the application. Again, it's a test, and test should be developers. It shouldn't be other folks testing your application. So that's the philosophy of this project.
Okay, I have other questions, but I think it's a follow-up that I'll catch up.
One final comment about the question is the nice thing here is that if you developer already have this kind of test cases, and they should, they can reuse it. Because here's a very simple test, but we have customers that have very complicated user journeys that have different requests to different services using very complex patterns and a lot of validations. And you can just reuse that and say, okay, what's happening to this user journey if I increase the latency of this service by 100 milliseconds? What happens? You can reuse all this logic that only the developer really know, the QA, depending on the organization, and just reuse all this knowledge of the application behavior and just test what's happening to this logic or these user journeys under specific failure conditions.
Hello. So how would you recommend introducing this in a CI environment, or in a way, because if you run this once, you know that you have certain condition, you can reproduce it. But then time passes, time goes by, and you introduce changes in your system, and you want to somehow keep testing the same thing over and over again. But this is a very expensive test, as far as I can tell. So how would you recommend introducing this in a CI environment, or how frequently would you run them?
Okay. You mentioned, just to clarify, what you see, why you think it's expensive?
First of all, I would assume that you need to create a cluster, maybe start up some services in the cluster and things like that. But yeah, unless you are running it in a station environment.
Yeah, actually, that's the idea. The thing is that because of how this works, you can kind of use some shared environment. You don't really need, and as you are not reproducing the real stuff, as you are not really, you don't really have to introduce a lot of load to reproduce. You can really have a very minimal thing. I mean, running this application in my machine. It can run in any CI. Using kind for running this. And it's a very huge application. You see, it's a lot of services there. Actual databases, but you don't really need, that's the beauty of this approach, is you don't really to replicate the real stuff anymore. If you have the minimal thing to make an integration test, I mean, if you are able to run integration tests, you can do this. That's what you did. Exactly, that's what the objective I have when the first time I think about it was exactly that, because it's the minimum. I mean, less than that is, okay, you have another problem. You're not testing. Okay, forget about chaos. It's just you are not testing your application at all. So if you can run an integration test, you can do this. On top of that, you don't need any more.
Nice, thanks.
Thank you very much. And sorry again.
Thank you, everyone. Our speakers, of course, Victor and Pablo, and Globo for hosting us. We're waiting for the pizza, so 5 minutes probably with the pizza. We have 4 drinks. And I'm trying to share a survey that if you can fill up, we'd be thankful. Give us your feedback. Finally, we're always looking for community speakers to share your case, so reach out to me or anyone. Grafana, if you want to share your use case in the next meetup, be very happy to host you.
Yes.
Esa parte de que es el estado de los concretos.
Cube state metrics. Es parte de, si no me equivoco, se instala por defecto. Si instalas Prometheus Operator.
Okay.
No, pienso que no está por defecto. Si vas por la ruta de Grafana, quiero decir, Grafana Stack, pienso que no está allí,
vale,
pero puedes instalarlo por separado.
Claro.
Cube state metric es especialmente el power. Estas son las cosas que quiero y